Assalamualaikum and a very good morning. So today we are going to present about our Apex project, which is Habit Power Plant under the theme of conservation of energy. So based on laws of conservation of energy, it states that the total energy of an isolated system will remain constant. Energy can be neither be created nor be destroyed, and also whether be transformed or transferred from one form to another. So in our project, we will combine hydropower plant and solar power to double the harvesting of electric current. We also have three main objectives, which is to improve the renewable energy sources. We want to make use of the renewable energy, which is solar and hydro, and to create a more dependent, yet we still consider the ability of the sources in Malaysia. And we also use storage hydropower plant instead of the others because it's the most common type and it can store large volumes of energy.
Next is component of hydropower plant. Firstly, dam. The function of dam is to store water. Next is turbine. Turbine will turn by the force of the water on their blades. Thirdly is generator. Generator rotated by the turbines to generate electricity. And lastly, transmission line, which is to conduct electricity ultimately to homes and businesses. Okay, next is Faraday's law. We use Faraday's law in our hydropower plant. Usually, Faraday's law lies behind most of the power plants. The basic principle is that mechanical energy is used to rotate a turbine, which then powers a generator that produces electricity. And it is used in the turbine and generator. Now, I will relate the Faraday's law with our hydropower plant. When the water that is stored in the dam and then released flow through a penstock inside the dam, a turbine propeller is fixed at the end of the penstock, and this gets turns by the force of the moving water. This converts the energy in water into mechanical energy because of the turbine was connected to the generator, which converts the mechanical energy into electrical energy, thus generates electricity. Next.
For the solar energy, a photovoltaic power system, also PV system, is power system designed to supply usable solar power by means of photovoltaics. It consists of an arrangement of several components, which are solar panels, photovoltaic arrays, DC-AC inverter, and transformer.
Next, the best condition for the photovoltaic power plant to be function well by the performance of high density thermoplastic HDPE as the main floats which known for its tensile strength, UV and corrosion resistant in the constructed FPV system, and it was set at a 12-degree angle to support a standard 60-cell PV solar module. And there is a secondary non-slip HDPE float was then used to main floats together and provide a platform for maintenance and added buoyancy as shown below in the picture. There are 7 main components for photovoltaic power plant, which are major floater, subfloater A, subfloater B, subfloater C, solar module, combiner, solar cable. For the subfloater A, B, and C, act as the walkways for easy accessibility during maintenance works. This basic structure is widely used around the world for FPV power plant because of the convenience of obtaining the system is also possible. And there is also an anchoring system that will help the photovoltaic power plant to stay at the fixed position all the time, even though there are some resistance occurs. There are anchoring system at the water banks and also at the bottom of the sea as shown in the picture above. Next.
Alright, so this is how photovoltaic power system PV works. Firstly, the power panels will absorb the sunlight and convert it into electrical energy. And the photovoltaic arrays are main components for the conversion of sunlight to electrical energy. The inverter are important to convert DC power to AC power before being transmitted to the grid. And transformer are used to step up the lower voltage to higher voltage. And for the conservation of energy, solar panel efficiency represents as a solar panel's ability to convert sunlight into electrical energy. And this is related to the ability of panel to convert energy at low cost and high supply rate. So to calculate the efficiency of panel, this is the formula, which is the maximum power divided by input power.
Now I will continue about how to calculate hydropower. Okay, this equation is the main equation that we should know to determine the amount of electricity generated by a potential hydroelectric power site. Okay, so P equal to H times Q times 62.4 times 0.746 divided by 550 times E. As we know, P is a power in kilowatt, H is head in feet, Q is a flow in cubic feet per second. 62.4 is a weight of 1 cubic feet of water. 0.746 kilowatt equal to 1 horsepower. 550 foot is equal to 1 horsepower. Is E is an overall efficient factor that usually 0.5 for small microhydro system. It was combining and reducing all these factors result in the following equation. Kilowatt times H times Q divided by 24 when using CFS, or W equal to H times Q divided by 12 when using GPM.
Now I'm going to present to you about hybrid pump storage hydropower plant. So this is one of the modification we're going to do to the hybrid power plant. So what is hybrid going to do here is a hybrid system to provide backup for the shortage of the main energy generation of operating together with an energy storage system. So the result of this, we are going to obtain hybrid power plant system using hydropower plant and floating solar photovoltaic. So how this thing is going to work is we connect the pump to the solar photovoltaic system, and these two pumps are connected from upper reservoir to the lower reservoir and vice versa to allow the flow of water. So, and then one of the two will be connected to the generator to produce electrical energy, while the other will be connected to the pump. So now I'm going to present about hybrid solar hydropower plant with connection at the transformer. So this is the second modification. So first of all, we're going to do is combine the two renewable energy generation system. So the next one, the photovoltaic system will be connected to an inverter to convert the DC power to an AC power. So after converting, both generated power will be input into the transformer to step up before sending it to the grid for distribution. So the advantage of this, we do not have to destroy the ecosystem to make space for photovoltaic panel.
I will continue with the next type of hybrid. But first, my name is Nofarah Alika binti Sulaiman. So the next type of hybrid is hybrid solar hydropower plant with battery storage. So we need to store the generated power before distribution at the grid. And since the availability of the set is actually very limited, combining and storing the energy generated in batteries will be a good solution. So the power generated by both systems has to be in DC to be stored in the battery. For this type, the AC power generated by the hydropower system has been converted into the DC power, but then the power will be converted back into the AC power before being input into the transformer for the regulation process. So other alternatives to make a different connection is where there will be two connections between the transformer and the plant systems. One of the two will connect the power generation system directly to the transformer, while the other will connect the system to the battery and then to the systems. By applying this combination, we can either use the power generated directly or store it for the future use. The next type of hybrid is hybrid solar hydropower plant with connection at the grid. So both photovoltaic and the hydropower plant will not connect internally, which means they use different plants to generate power, and then the power will be directly connected to the grid for the distribution. And this system is actually the simplest and the easiest design. But it might require a large cost since we need to build two different systems. And in addition, it might require more space since PV systems are mostly installed together with the battery storage.
Okay, now I'm going to talk about a project model diagram. So first, we have to use container A, container B, dynamo, solar panel, plasticine, rope, polystyrene board, and emitter. And for the methodology, first of all, we have to place a small container, which is container A at high level as a dam, and attach a dynamo with turbine at the edge of the dam and connect it to a transformer. Next, prepare a bigger container, which is container B, which is transparent as the body of the model. Make a small hole at one of the container, which is container B, to allow excess water to flow out when the container is full of water, and place a pail under the hole. Next, pour water into the dam, which is container A, so that the dam can function and the turbine can move to generate electricity. And then attach a solar panel on a polystyrene so that the solar can flow. And for the anchoring system, first of all we have to measure the depth of the water in the container B when the water is low into the container B, and then attach rope at each edge of the polystyrene, and put a plasticine at the end of the rope and stick the plasticine on the base of the container B to anchor and secure the solar panel at one place. And then connect the solar panel to the emitter. And lastly, place a light source near the solar panel so that the solar panel will convert light energy to electrical energy. And for the responding variable, the emitter reading or the energy produced. When the needle emitter deflects to the right, this shows the more energy is generated. When the needle when the needle of emitter deflect to the left, this shows that less energy is generated. And then manipulator variable, the presence of solar panel. Presence of solar panel will absorb sunlight to generate more energy and combine energy from hydroelectric from the dam. Absence of solar panel, less energy is generated because the only energy generated is from hydroelectric from the dam. Control variable, size of solar panel. The size of solar panel is kept constant because larger solar panel absorb more sunlight to convert more light energy to electrical energy, while smaller solar panel absorb less sunlight and convert less light energy to electrical energy. This is our Gantt chart. So on 20th, first we have to group formation, and then the next day site leader, then the next day information finding. 23 August, we have decided the project title. On 24th, we are finding concept and sketch model. And 26 August, we have discussed project model. And 2nd September, we are compiling data. And at 5th September, we prepare a slide. Okay, that is all for us. Thank you.